Example 1 here on the product rule is simply using the product rule. So say we have the function here, y equals e to the x sine x. All we want to do is simply find dy by dx. So here we need to use the product rule because this is the product of two functions. My first function here, u of x, is simply e to the x. And my second function here is sine of x. Okay, so let's call that v of x. So as this can be expressed as the product of two functions here, we simply need to use the product rule. And here what we'd do now is find the derivative of u of x with respect to x, so we'll write that as u prime of x. We also need the derivative of v of x here with respect to x, that's v prime of x. Well, the derivative of e of x with respect to x will simply give us e to the x there. Okay, so that doesn't change. And for the derivative of sine x here with respect to x, that would just simply give us cos x. Okay, so we've got everything we need now. What we simply need to do is apply the formula for the product rule. So therefore, dy by dx is simply going to be u of x times the derivative of v of x here, so that's v prime of x, so that's going to give us e to the x times cos x, and then we add on v of x times u prime of x, that's going to be e to the x times sine x, so e to the x sine x. Okay, and we can just simplify this a little bit here by factoring out e to the x. Okay, so we can express this as e to the x, and if we just write this in this order here of sine x plus cos x, but clearly this wouldn't matter here. Okay, we'd get the same result either way, e to the x bracket sine x plus cos x there. Okay, and that gives us dy by dx there, and gives us the solution to example 1. Example 2 here on the product rule is using the product rule for larger functions. So here, this is where we're going to need now our extension to the product rule formula. Now here, the reason we need to use an extension is because our original equation, y equals x squared minus 1 times the natural logarithm of x times cos x, is the product of three functions here. So here in this case, what I'm going to do is define each of these functions separately, differentiate all three of them, and then we can apply our extension to the product rule. So here, let's u of x be equal to x squared minus 1. Let v of x be the natural logarithm of x. And finally let w of x be cos x. Okay. Well, in this case here now, if we differentiate each one of these separately with respect to x, my first one here, u prime of x, would simply be the derivative of x squared minus 1 with respect to x, giving us 2x there. Okay. If we differentiate v of x now, so that's v prime of x, with respect to x, so the derivative of the natural logarithm of x simply gives us 1 over x there. Okay. And finally here, w prime of x will simply give us minus sine of x. Okay. So we've got everything we need now. Simply all we need to do is work out dy by dx, and then verify that there's a stationary point at the point 1, 0. So here, dy by dx is going to be an extension now to our product rule. Well, in this case here, what I'm going to do is start with my first derivative being w prime of x, and then work across with my second one being v prime of x, and then finally u prime of x. So the first part here is going to be u of x times v of x times w prime of x. Okay, and what we'll do here is we'll split this up into three colours just to highlight what we're doing. So the first one here is going to be, so what I'm going to do is, as this is minus sine x here, I'm going to place the minus at the very front here. Okay, so it's going to be minus x squared minus 1 times the natural logarithm of x. Okay, and then times, in this case, sine x, so we brought the minus to the front. Okay, so that's the first part here. So we've done u of x times v of x times w prime of x. Okay, let's represent the next part in blue. So here now, what we're going to do is u of x times w of x times v prime of x. Okay, so in that case here, it's going to be plus x squared minus 1 times cos x times 1 over x. And for now, I'm not going to do any simplification just yet. We'll do that on the next line. Okay, so that's the second part where we've done u of x times w of x here times v prime of x. And finally here, if we represent this final part in orange, we're going to do u prime of x times v of x times w of x. And in that case here, what we get is plus cos x times the natural logarithm of x here times 2x. Okay. So here we've got everything we need now. All I'm going to go on to do is simplify each part individually. Okay. What we'll do is we'll just go back to our original pen colour here. So I can write this now as 2x times the natural logarithm of x times cos x. Okay. Plus, so putting this now over this x here, I'm going to get x squared minus 1 cos x. So we'll put this in a bracket here, cos x, and this is all over x here. Okay. And finally, we have minus here for this first part. We put this in a bracket here as well. It's going to be x squared minus 1 times the natural logarithm of x times sine x. Okay. So here now, we've got dy by dx. This is our expression for dy by dx. So simply all we need to do here now is verify that there's a stationary point at the point 1, 0. So if there's a stationary point at the point 1, 0, all we need to do here is substitute x equals 1. That's what this is telling us here. X equals 1 into this equation here for dy by dx. And if there is a stationary point, this expression here should be equal to 0 when x is 1. So therefore, if we substitute x equals 1 into this now, what we get here is 2 times 1. That's 2 times 1 times the natural logarithm of 1 times cos 1. So that's the first part here. That's this part. Now clearly, the natural logarithm of 1 is equal to 0. So this full expression is equal to 0. Here now, again, substituting x equals 1 in, I've got 1 squared minus 1. So that's going to be 0 times cos of 1 over 1. Okay? So that's going to be 0 times cos of 1 over 1. And again, this expression here will give us 0. And finally, if we put 1 into this expression here, where we've got x, so that's 1 squared minus 1, which gives us 0. We've also got the natural logarithm of 1, which would also give us 0 there as well. So in that case, this part here will give us 0 times the natural logarithm of 1. So in fact, let me just rub that out, just so we can put the multiplication symbol in here. So that's going to be 0 times the natural logarithm of 1 times sine of 1 here. Okay, and again, this part here will just simplify to give us 0 here. So that would be minus 0, but clearly 0 plus 0 minus 0, we get 0 either way. Okay, so what we can simply say here is therefore dy by dx is equal to 0 when x equals 1. And therefore, as dy by dx equals 0 when x equals 1, that verifies the fact there that there's a stationary point at the point 1, 0. So there is a stationary point. So there is a stationary point. When at x equals 1 there. Okay, and that gives us the solution to example 2 there.